Last one, number 10. They tell me tan theta is equal to 4. And you can use identities or triangles to find the exact value. By identities, I mean like the Pythagorean identity, the complementary angle identities. For example, you can use the complementary identity angles for letter C. C asks for cotan of 90 minus theta. Well, that's the same as tan of theta, so it's just 4. Or you can use triangles. You all may find it easier to use triangles, so that's what I'm going to do. Start over here, draw the triangle. Alright, so tan is 4. That's 4 over 1, so that's opposite over adjacent. So, bad to scale drawing here. This becomes 4, that becomes 1, that's theta, that's a right angle. Now I'm going to use Pythagorean theorem. A squared plus b squared, so I square 4, get 16. Square 1, get 1, add them, 17, square root them. That makes this side root 17. Alright, now A. So now I'm going to use this triangle to answer all the questions, which is kind of nice. So A asks for secant squared of theta. So you need to know what secant is paired with. So secant squared is 1 over cosine squared theta. So cosine is equal to adjacent over hypotenuse, so that's 1 over root 17. So it's 1 over root 17 squared, which looks complicated, but really not that hard. So that's 1 over root 17 squared. Well, yeah, 1 over root 17 squared just gives me 1 over 17. That divide by fraction to divide by a fraction, I multiply by the reciprocal. So I do 1 over root 17, which is just 17. That's the answer for that. All right, B. Cotan, super easy. Sorry, let me give space here. Whatever, who cares. B, cotan of theta. Be careful that you're doing what they're asking. So it asks for theta this time. So cotan is for theta there. It's adjacent over opposite. So it's equal to 1 over 4. You can also just take that value, tan of theta equals 4, and do 1 over it, because that's how tan and cotan are related. So that's really like using the identity. What I did here is using the triangles. Pause for a moment. Alright, I kind of said out loud how to do C using identities. It's just 4 because tan and cotan get the 90 minus theta thing. Tan of 10 is the same as cotan of 80. So since this angle up here, I'll call it angle dot. How about that? Angle dot, angle blob is complementary with theta. Anyway, let's get rid of that. Using triangles, if I talk about angle blob, so it asks for cotan of 90 minus theta. Well, 90 minus theta is the blob, because if theta was 10, the blob would be 80. So that's equal to cotan of blob, I will call it. And that is adjacent over opposite for the blob. So this is the adjacent, this is the opposite, so I get 4 over 1, which is just 4. Last one, cosecant squared. I'm going to give myself a little more space. Alright, cosecant squared of theta. cosecant is equal to 1 over sine squared theta. So I need to find sine squared theta, and then I need to do 1 over it. So that gives me, and this is one that's probably easier to do using triangles as opposed to identities, because we haven't really talked too much about this particular identity, although we did talk about it. Anyway, actually, I'm not even going to do it that way. Sorry if this is annoying, but cosecant, well, sine, I'll write down here, sine is O over H. Cosecant of the same angle is H over O. So, instead of doing like weird fraction stuff, I'm just going to do H over O and square it, because that's much easier. So, the hypotenuse is root 17. So, I'll do a little intermediate stuff here. So that is H over O squared. So that gives me root 17 over, opposite is 4 squared. So, blue, that gives me root 17 squared is just 17. 4 squared is 16. And that's your answer there. That's all. Done. Yeah.